All right, welcome back. So just a little bit more left this week before we get into the really good stuff next week. I want to talk about how we've talked about what are radians, how do we compare them to degrees, how do we use that to complete the unit circle. So the last thing we're going to do this week is use our unit circle and our degrees knowledge to find trig values of radians, just like we did with degrees. So the first thing I have here is this is the first quadrant of the unit circle, quadrant 1. And so just like before, we might think about, what are the degrees, radians, and x and y coordinates of all these points here. So we know we've got 0 degrees, 30 degrees, I'll zoom in just a little bit more, 45 degrees, 60 degrees, and 90 degrees. Now I'm going to go ahead and fill this in with our radians, our x and our y values. If you'd like to test your knowledge of the unit circle here, you could actually pause, fill in their radians, and then check back in, and then we'll do the other coordinates as well. So we have 0 radians, pi sixth radians, pi fourths radians, pi thirds radians, and pi halves radians. Now again, you could pause and test your knowledge of the x and y coordinates before I fill those in. Oops, I've already got that mixed up. This should be 1, 0. And then we've got root 3 over 2 and 1 half. And then we have root 2 over 2 and root 2 over 2. And there's a comma there, right? That's a coordinate point. And then we have 1 half, root 3 over 2, and finally 0, 1. So this is just one of those, if you know quadrant 1, you can use your logic and your intuition to fill in the rest of the unit circle. So again, in a normal year, a normal learning period, this is something I would ask you to do, is I would ask you to memorize these values. So if you have an opportunity to kind of start to pull those together, go for it. So let's remind ourselves of our trig values, right? We know SOHCAHTOA, great, but the unit circle gives us a shortcut here. So we've got sine of any angle theta. We've got, actually, let me just change my colors here, sorry. We've got sine of any angle theta. We've got cosine of any angle theta, and we have the tangent of any angle theta. So the unit circle makes this really nice and easy. Our sine of any degree there is equal to the y coordinate of that coordinate point. The cosine is equal to the x coordinate. And then tangent, if you watched that video last week, tangent of any angle theta is equal to sine of theta divided by the cosine of theta, which for us will be the y value divided by the x value. So just like last week when we were looking at how do we find this or use the unit circle, to find trig values for degrees, we're doing the same thing here just with radians, a little bit more practice. So a couple of examples here. So the first example, let's find the sine of pi thirds. So pi thirds is our right equivalent to our 60-degree angle there. So the sine is the y coordinate, right? So sine of pi thirds is equal to root 3 over 2. If you hear any whining in the background, that's just my puppy dog who's a little bit jealous that you're getting all my attention and not him. Sorry. So our cosine of pi over thirds is 1 half, right? Our x coordinate. And then our tangent of pi thirds, we're going to do our y value divided by our x value. So sine over cosine. So, oops, a little bit too far. So this will be root 3 over 2 divided by 1/2. Now remember your fraction, your division of fractions, you can call that multiplication of a reciprocal, so root 3 over 2 times 2 over 1. We get some nice cancellation. Those 2 over 2 reduce to 1 over 1, and this will reduce to or equal root 3 over 1, or simply root 3. So again, the unit circle gives us this nice little shortcut here to find those trig ratios. Otherwise, we would be, making triangles over and over and over again, but the unit circle does that shortcut for us. So a couple more examples here together, and then these other practice problems are for you to try on your own. So cosine of 1/2, 1/2 pi, or pi halves, that will be the x coordinate, or 0. Sine of pi sixths, that will be the y coordinate of pi sixths, that will be 1/2. And then tangent of pi fourths, again, we're going to do our y divided by our x, so root 2 over 2 divided by root 2 over 2. Now, you might see the shortcut here, right? We're taking a number and dividing it by itself, which is equivalent to 1, right? Any number divided by itself is equal to 1. But if you just need to go through all the steps yourself, you can see that we've got root 2 over 2 reduces to 1, and 2 over 2 reduces to 1. So our tangent of pi fourths is equal to 1. So you might want to copy and paste your full unit circle somewhere over here so you have a quick reference, or you can go back and forth to it. Or if you're really feeling like you're ready for a challenge, you can try all of these examples on your own using just the first quadrant and see if you can infer the values for all the other quadrants as well. Either way, you know what's best for you right now. Let me know if you have any questions. Again, you're doing a great job just staying engaged. I'm so proud of you, and let me know if you need anything.